Hello friends, welcome to the course of Computer Network. This lecture is in the continuation of the last lecture in which we started discussing about reliable data transfer protocols. And in the last lecture, we discussed about RDT 2.1, Reliable Data Transfer 2.1 version. And today we are going to discuss the next version of our protocol, that is RDT 2.2. And this RDT 2.2 version is very similar to RDT 2.1, but in RDT 2.2 version we do not have the concept of negative acknowledgement. So RDT 2.2 version is a NAC free environment, and that we'll see shortly. This particular protocol is completely NAC free protocol, or without negative acknowledgement we will accomplish a task. So in this particular protocol, instead of sending a negative acknowledgement back to the sender side, we send acknowledgement of the last correctly received packet, so that sender will get to know that the packet which I just sent is not properly received by the receiver. That is why receiving side has sent me the acknowledgement of the last correctly received packet. So here you see these are the two states in our RDT 2.2 version. This is wait for call 0 from above, wait for acknowledgement of segment 0. This RDT 2.2 version FSM has 4 states, but in this diagram you see only 2 states. These 2 states belong to segment number 0. This particular FSM may have 4 states, the next 2 states for segment number 1. So here we'll understand this with the help of uh, segment number 0 only, because segment 1 is not required, because RDT 2.2 is very similar to RDT 2.1. The only difference is RDT 2.2 is NAC free protocol, and instead of sending a negative acknowledgement, receiving side sends a acknowledgement of the last correctly received packet. That's how it works. So here is the simple case as we saw in our last protocol RDT 2.1, wait for call 0 from above. So here transport layer uses the reliable data transfer protocol, and it designs a segment along with the checksum field and sequence number, and it sends it through unreliable data transfer protocol, because that data has to go through the network layer, which is completely unreliable, but network layer gives you the best effort delivery. So once sending side is done with the data transfer, it will switch its state to wait for acknowledgement 0. That means it's in a state, it is waiting for the acknowledgement of segment number 0, which this particular sender has just sent. So two possibilities are there: if the received packet is corrupted, or that packet is acknowledgement of sequence numbers 1, that means segment 1, which was the last sent packet. So in this case your sending side will do nothing, it will just retransmit the packet again. Why? Because either your packet is corrupted, or receiving side is sending the acknowledgement of last received packet, because you can understand it by seeing this one. This acknowledgement is of segment number 1, which this particular sender sent before this particular segment number 0. So in both the cases, your sender will send again or retransmit packet number or sequence number 0 to the receiving side. And the other possibility is, in this particular state, if this particular sender or this particular state receives a packet which is not corrupted, and it is an acknowledgement of segment number 0, which it is expecting or which is expected at this particular state. If this thing happens, then it will switch its state to wait for call 1 from above. So here that stage will be here. So it is just to make you understand that without using negative acknowledgement, we can use the protocol, and this protocol would be a knack free protocol. And we'll see the receiving side as well of this particular RDD 2.2 protocol, in which we find this state which says wait for 0 from below. That means this is a receiving side which is waiting for segment number 0. We have three possibilities, but only two possibilities are showing in this particular slide, because rest of the diagram of this receiving side will remain same for segment number 1. So if we are in this particular state, our receiver is waiting for segment number 0, then two possibilities are shown over here. The first is if the received packet is corrupted or it has a sequence number 1. That means either it is corrupted or it has a sequence number 1, which is not expected over here. We are expecting, or this receiver is expecting, segment number 0, but it receives segment number 1 or a corrupted packet. Then in that case, our receiver will create a packet with the acknowledgement number 1, which is the acknowledgement of last correctly received packet. As you can see, we are waiting for 0. That means the last packet which we have received, or this sender has received, would be segment number 1. So you can see over here, we instead of sending negative acknowledgement for the corrupted packet or for this particular sequence number, we are sending acknowledgement of last correctly received packet, that is segment number 1. So we are sending it through the unreliable data transfer protocol. So that is how it is done without using negative acknowledgement. The second possibility which is shown in this particular diagram or slide at the receiving side is the received packet is not corrupted and it has a sequence number 1. It says 1, but this thing is for this particular side, because you can see the arrow side. It is coming from this side to this side. If this side is wait for 1 from below and you receive a packet which has a sequence number 1, that means whatever packet you are expecting, you got that packet. In that case, what you will do, you will extract the data from the packet, you will deliver that data to the upper layer, which is application layer, and you will design a packet which is an acknowledgement of the packet which you have received along with the checksum field, and you will send it through the unreliable channel or unreliable protocol to back to the sender. So that is how this RDT 2.2 version works without using negative acknowledgement. And it's like it provides you a knack free environment, and it is a knack free protocol, which is RDT 2.2. Okay, now moving to our next slide. This this says RDT 3.0, and it is our next version of reliable data transfer protocol, which is RDT 3.0. And this particular version is all about channels with errors and loss. Till RDT 2.2, we assumed that the channel may produce some error in our data, but channel is reliable enough not to lose our data, but it may produce some bit errors in our data which is going through that particular channel. But in RDT 3.0, what we are assuming, that channel with errors and loss, your data may get lost during transmission, and that particular channel may produce some error in your messages. So how we are going to cope with this particular situation when the channel is not perfectly all right? It may produce errors, data may get lost. So what we are going to do, we'll see in the next slide that this is the sending side of our RDD 3.0, in which our data may get lost. If you assume a situation where we have a sender and a receiver, and sending side sends the data, and that particular data lost in between, and receiver never receives any data, then why would receiver send an acknowledgement or negative acknowledgement or acknowledgement of last correctly received packet back to the sender? Why it will send that acknowledgement to the sending side? So in that case, our protocol will get stuck, because sending side will never get acknowledgement of that lastly send packet, and once it will not get the acknowledgement, it will not send the next packet, because the protocol which we are discussing over here is stop and wait, as I told you in the last lecture, that in stop and wait protocol, sender sends the data. Once that particular data or packet is acknowledged by the receiver, then only sender is allowed to send the next packet. But it doesn't happen in that case. If your data, sorry, if your channel is lossy, then for the lossy channel in RDD 3.0, what we have improved, we included a timer in this particular protocol, and we'll see over here how this timer will save our data or our protocol, which can get stuck if our channel is lossy. So you can see over here, we start with this particular state, wait for call 0 from above. That means we are waiting for segment number 0. Once we get the data, our transport layer creates a segment along with the sequence number and checksum, and send it through unreliable data transfer protocol. But this time you see one more thing over here. Once your data is sent from the sending side to the receiving side, you start a timer. You start a timer for uh, that particular packet, and if your timer is time out, then only you can retransmit that packet. Okay, you can see over here, once your data is sent from the sending side, you will flip your state to wait for the acknowledgement, waiting for the acknowledgement for segment number 0 which you just sent. Now over here we have got three possibilities. First one is this, second one is this, and third one is this. So first of all, we will discuss this particular possibility. Okay, when you're waiting for the acknowledgement of segment number 0, and you receive a packet which is a corrupted packet, or that packet is not the acknowledgement for segment number 0, that is the acknowledgement of segment number 1, then in that case you will do nothing. This time you will do nothing, you will not retransmit the packet, you will again remain, you can see this loop, you will again remain in this particular state for wait for acknowledgement of segment number 0. Now the second possibility is, after this what happens, your if timer gets time out, the timer which you have started over here when you send segment number 0, you started a timer. If that timer times out, then what you have to do, it's very simple. If your timer times out, that means your data which you just sent from the sending side got lost during its journey to receiver. So that is why your timer times out, and now you have to retransmit that particular packet again through an unreliable data transfer protocol, and you start the timer again, and you will remain in this particular state till the time you don't receive acknowledgement number 0 of segment number 0. Now the third possibility in this particular state is if you receive the data, that data is sorry, not the data, the acknowledgement, that acknowledgement is not corrupted and that acknowledgement is of segment number 0 which you are expecting in this particular state, then your timer stops and you flip your state to wait for call 1 from above. So that is how this particular protocol works. It's a very beautiful protocol, stop and wait protocol, which is used for sending the data reliably. But there are some problems in this particular protocol because the utilization, channel utilization of this particular protocol is very less, because it's a stop and wait protocol. In stop and wait protocol, what happens, you send the data and until and unless you do not receive the acknowledgement of that particular data, you cannot send the next packet. So that is the disadvantage of this particular reliable data transfer protocol 3.0. But it is a reliable protocol because it is providing you the retransmission if your data get lost during its journey. And okay, and you see this particular protocol once again with segment number 1. It will be a kind of recap for you. Let's take example of segment number 1, that your sending side is waiting for segment number 1 from above. Once your sending side gets the data for segment number 1, what you will do, you will create a packet with sequence number 1 and along with the checksum, and you send that particular data through unreliable data transfer protocol, and you start the timer. You start the timer for that, for segment number 1 this time, and you flip your state from this state to this, wait for acknowledgement number 1. That means in this particular state your sender is waiting for the acknowledgement of segment number 1 which it just sent. Now again, three possibilities are there which we just saw over here. The first possibility is if you receive a packet which is corrupted, or it's an acknowledgement of last received, last sent packet. That means your just sent packet, which is segment number 1, got lost somewhere during its journey. Then you will do nothing. You will wait for the timeout. Once it is done, you will retransmit your packet again and you will remain in the same state, because until and unless you do not receive the acknowledgement of segment number 1, you cannot proceed and you cannot send the next segment. The third possibility is if you receive the packet and that packet is not corrupted and it is acknowledgement of your expected segment, which is segment number 1. You can see over here it says the sequence number is 1 for this particular acknowledgement. It means it's acknowledgement of sequence number 1. Then you will do nothing. You will stop the timer and you will flip your state. Now again you are ready to send the next segment with sequence number 0. So that is how we have a completely reliable protocol with the name RDD 3.0. It is also called a stop and wait protocol, but the utilization of this particular protocol is less. So that is why we will further improve our protocol in our coming lectures. Thank you very much. See you in the next lecture.